Hey everyone! So, today we're going to talk about something you probably haven't thought about since you were a kid, the good old multiplication table. But stick with me here because we're going to look at it in a totally new way. Not as something to just memorize, but as this incredible blueprint for how our brains actually make sense of the world.
So, let me start with a question for you. Just think for a second. What's the single most powerful tool you ever learned in school? Maybe you're thinking algebra? Or the scientific method? I'm going to make the case that it's something way simpler.
It all starts right here, with this, 1 times 1. I know, it looks almost ridiculously simple, right? But believe it or not, inside this one little equation is the seed for a system that lets us do incredible things. Build bridges, write software, even understand the universe. So the real question is, how do we get from this to all of that?
Well, it all begins with a single, foundational idea. Let's call it the bedrock of identity.
You're probably looking at this times 1 column and thinking, yeah, okay, this is the easy part. But it's so much more than that. This isn't just easy math. It's the first law we learn in this new world of numbers. 1 times 1 is 1. 2 times 1 is 2. See? It's teaching our brain a fundamental truth about how this whole system is going to work.
And this actually has a name. It's called the rule of identity. Any number you can think of, when you multiply it by 1, just stays itself. This is our anchor. It establishes that this system is stable, it's predictable, and it's not just a bunch of random numbers. It's the first unbreakable rule that everything else is built on.
All right, so once we've got that first rule locked in place, we can start to add a little complexity. And this is where the real magic happens. We do it by discovering the power of patterns.
Okay, now we take our first real step up. 2 times 2 equals 4. With this one problem, we've officially moved beyond the safety of that first rule, and we've actually started combining groups.
And let's do another one. 3 times 2 equals 6. What's happening in your brain right now isn't just rote memorization. It's a huge cognitive leap. Your mind is recognizing a repeating action, taking a group of 2 and doing it 3 times.
So let's break that down. What is our brain actually doing? It's kind of running a simple little program. First, it identifies the base group. In our last example, that was the number 2. Second, it repeats the action of adding that group 3 times over. And third, bam, it recognizes a predictable pattern that emerges. 2, 4, 6. We're not just memorizing answers, we're learning a process.
So we have our foundational rule, and we have a process for creating patterns. What's next? Well, now we organize the whole shebang. We create a map.
And you know, every good map has landmarks, right? Those familiar spots that help you get your bearings. In the times table, these are the square numbers. 2 times 2, 3 times 3, 4 times 4. They form this perfect diagonal line right through our map. They're these powerful anchor points our brain can just lock onto, making the whole system so much easier to navigate.
And here it is, our map, the grid. Now I know this might look like that boring chart you had on your wall in 3rd grade, but it's not just a collection of facts. It's a complete, interconnected system. Every row is a pattern. Every column is a pattern. And where they cross, you find one single predictable answer. It's a perfect map of how numbers relate to each other.
But here's the thing. So far, this is all just abstract. It's a game we're playing with symbols. The real power, the whole point of all this, comes when we take that final leap from this grid into the real world.
So let's just pull one fact right off our map. The grid tells us that 3 times 4 is 12. Okay, great. Right now, that's just an abstract piece of information.
But what does it mean? Who cares? Why does it matter? This question right here is maybe the most important step in the entire process of learning anything, connecting the abstract idea to a tangible reality.
And then this happens. Boom! The aha moment. You have 3 bags of cookies, and there are 4 cookies in each bag. All of a sudden, 3 times 4 isn't an abstract equation anymore. It's a tool for predicting exactly how many cookies you're about to enjoy. The abstract has become very real.
Let's do just one more to really see it in action. Here's a real-world problem. 5 boxes of pencils with 2 pencils in each box. Our abstract system, our grid, gives us the perfect tool to solve it. 5 times 2 equals 10. We just translated reality into the language of the grid, found the answer, and now we know for a fact we have 10 pencils. That is the payoff.
So why did we just spend all this time deconstructing something so seemingly simple?
Because this process, it's not simple at all. In fact, it's the very foundation of how we build pretty much all human knowledge. The journey we just walked through, that is a universal blueprint for learning. Think about it. We started with a simple, foundational rule, our rule of identity. Then we built up complexity by recognizing patterns. Then we organized all those patterns into a big, scalable system, our grid. And then, the most critical step of all, we applied that system to solve real-world problems. This is exactly how we learn to code, to speak a new language, to play music, pretty much anything complex.
And that brings us to one last thought. The multiplication table is just one obvious example of this blueprint. So the question I'll leave you with is this. What other simple foundational patterns have you learned in your life that are quietly structuring your entire understanding of the world? From the rules of grammar to the basics of genetics, that same blueprint is everywhere, just waiting for you to see it.